Sorry to keep you waiting. I lost track of time outside. Yeah, my name's Todd. I'm a cryptographer at Manta Network. We're a Polkadot parachain. And I'd like to talk a little bit about SNARKs, ZKP, and other things the NSA doesn't want you to know about. So I think we may not be in full screen mode. So ZKP and ZK SNARK, these are these letters that we see all over the place, right? Whenever we start talking about on-chain privacy, these letters start popping up. And I think that there's kind of a lack of good resources that explain what they are in a non-technical way. So that's basically the goal for today's talk, is to give a friendly introduction to what is a ZK SNARK. So I promise that I will not use any math. If you're a cryptographer and you work with these, I may bore you, but I'll try to entertain you at the same time. Time permitting, I will talk about what we use these for, okay? So what is a ZK SNARK? It's an acronym, and what the acronym stands for is Zero Knowledge, Succinct, Non-Interactive, Argument of Knowledge. This is perhaps a confusing definition, so you may go online and look into literature to try to get some help. But what you find will be even more confusing. This is taken from the Manta spec, Manta white paper, or an old version of it perhaps. And so what I'd like to do today is say what it is, give the idea of what it is without going into this whole mess here. So I'll tell you a story. It's a story that takes place about 2 years ago, so winter of 2020. And winter of 2020 was a strange time. Most of us were probably confined to our homes, and some of us went a little bit crazy during this time. I know that I did. And one of the ways that manifested itself is that I found a Rubik's Cube somewhere in my apartment, and I started playing with it casually at first, and then a little bit less casually. Because just so a quick show of hands, who actually knows how to solve a Rubik's Cube? Anybody? Not a whole lot of people. It's hard. It's damn hard, actually, right? So I started spending a lot of time trying to solve the Rubik's Cube, and it got to be an obsession, a real obsession, and I couldn't do it. I could come awfully close, but I couldn't quite do it. And so I went online. I thought, well, all right, I'll accept help. What you find online is not what I was after. When you go online, you'll find algorithms for solving the Rubik's Cube, right? Steps that you memorize that will, yes, lead you to a solved Rubik's Cube, but it's not actually what I wanted. I wanted someone to kind of explain to me how does the Rubik's Cube work so that then I can solve it myself. So I needed a teacher, right? I needed a Rubik's Cube instructor. So that's what I searched for. I searched for Rubik's Cube instructor. It turns out that doesn't exist. Universities do not give degrees in the Rubik's Cube. Governments do not certify Rubik's Cube instructors, right? You're totally on your own when you need a Rubik's Cube instructor. I said, that's okay. I will find one myself. So I went to a tutoring website and I posted an ad. I said, hi, I'm a very motivated student of the Cube, and I would like an instructor who can teach me how to solve it. I'll pay $100 for a session where you teach me how to solve the Rubik's Cube. But of course I have to, before paying them, I have to verify that they can solve the Rubik's Cube. And as I said, there is no central authority like a university or a government that certifies people in their ability to solve the cube, so I have to do it myself. I have to come up with some way for someone to prove to me that they can do a thing, right? And this is what ZK SNARKs are about. So it's a good time to introduce a little bit of terminology around ZK SNARKs. They always start with a statement. And in this case, the statement is, I can solve the Rubik's Cube. Someone has to prove to me that they can solve the Rubik's Cube. So they want to prove the statement, I can solve the Rubik's Cube. And that person is called a prover. We refer to them as the prover, right? And in my example, it's this Rubik's Cube tutor. They produce some kind of proof that they give to a verifier, which in this case is me, because I'm the one who needs to verify that they can solve the cube. And then there will be some protocol that tells me what to do with their proof in order to determine if it convinces me or not, okay? And filling in each of these 4, perhaps 5 if you include the proof, blanks is what it means to define a zero-knowledge proof protocol, okay? So I will walk you through a zero-knowledge proof protocol for, finding Rubik's Cube tutors. So the worst version that you could use, this doesn't work, but it's a simple example, is you could ask them to send you a picture of themselves holding a solved cube. You're laughing because it's obviously a terrible proof, right? How do I know that they solved the cube? How do I know that it's not a brand new cube that's never been shuffled, right? So but okay, suppose that were the proof, then the protocol would be they send that proof to me, I look at that picture, and I've confirmed that the cube in the picture has been solved, right? So that's what I mean. I accept the proof if it's solved, I reject it if it's not. So there's a slightly, that's not convincing, right? So we need the proofs to be convincing. And one way that you could make that proof convincing would be, and this is what I did, I added to my ad online, I said, by the way, before I pay you, you're gonna have to send me a video where you shuffle a cube and then solve it, right, in the video. Because I think that that's reasonably convincing, right? You could object, you could say, let's not go there, right? That's reasonably convincing. And I got this reply. Someone said, hello, I'm good at the cube, I would love to tutor you, but I'm sorry, I'm not willing to send you a video of me solving the cube. I said, well, why not? He says, well, if I send you a video of me solving the cube, how do I know you won't just study that video and learn how to solve the cube from the video, right? And then you don't need me anymore and I'll never get paid. And actually he has a very good point, right? The proof ought to be convincing to me, but it also ought to guard the secrets of the prover, which in this case are his secret Rubik's Cube solving techniques, right? And so if you send me a video of you solving the cube, it is actually true that you might leak some of your techniques to me in the video. And so we have a real problem, right? We have this situation where both parties want something kind of opposite. The verifier, I want the proof to be as convincing as possible, right? Which generally is going to mean that it should contain more information. Kind of intuitively, the more information it contains, the more I'll be convinced, right? The prover wants the opposite thing, right? They want the proof to contain as little information as possible because this is information that they are not willing to give away, at least not for free. And so it seems hopeless at first. And in that cold winter of 2020, I sat down and I thought for a while about what we could do about this, right? Just appreciate for a second how hard, right? How hard zero knowledge proofs are, right? Because you have to balance those two things. All right, here's what I came up with. Usually when we talk about solving the cube, it means taking a shuffled cube and moving its faces until one face is red and one face is green and one face is yellow, etc., right? And that's the traditional solution to the cube. But a true master of the Rubik's Cube would actually be able to do something much more impressive, right? They would be able to take a cube that is shuffled and put it into any other valid configuration of the cube, if they truly understand how it works. You see what I mean? Like, there are certain configurations that are valid for the cube, and if you really, really understand the cube, then you would be able to put it from one configuration into a different configuration. It's much harder. I admit, it's much harder, right? But I am going to pay you $100 to teach me, so it's not unreasonable to ask that you be good at it. So then what I did is I shuffled my cube and I took pictures of all 6 sides. And I sent those pictures to the potential tutor. And I said, okay, don't have to send me a video. What you have to send me is a picture of yourself holding a cube that is in this exact configuration that I just gave you. That might be 2 pictures, I guess, so that I can see all 6 faces of the cube. But anyways, that there is actually a satisfactory proof, right? It is convincing to me because if I shuffled my cube randomly, then I have it in one of the approximately billion configurations of the Rubik's Cube. And it is highly unlikely that someone who doesn't know how to solve the cube would ever achieve that configuration just by dumbly, shuffling it around. It's not going to happen. It's astronomically low. And from their point of view, it's also totally acceptable because sending me a picture of a cube in a given configuration, it tells me absolutely nothing about how you put it in that configuration, right? So we have a successful zero-knowledge proof protocol, right? So to be really clear about it, the protocol is this. I, the verifier, send you a picture of a shuffled cube. You, the prover, put your cube in that position and send me pictures of it. And then my protocol for verification is I look at your pictures and I compare them to my cube and I make sure that they match. Accept if they do, reject if they don't, right? And that's it. Like if you follow that, then that's a zero-knowledge proof protocol now, right? It's not a very useful one. It only actually works for this one statement, I can solve the Rubik's Cube, but it works really well for that statement. And it illustrates some of what we needed to explain about this definition, right? So I'll just go back through this quickly. Now that we kind of have an example in mind, I think we'll understand it better. So zero knowledge, this protocol is zero knowledge because their proof doesn't teach me how to solve the cube, right? So there's in a sense, zero knowledge contained in their proof. It's a picture of a cube in a position. There's not much knowledge to be extracted from that picture. Now, succinct is a thing I don't want to define precisely, but it roughly means that the proof is small and can be verified quickly. And let's just agree that 2 pictures of a cube is a small proof, and that me checking those pictures against my cube is a succinct verification. We'll just agree to that, okay? Non-interactive is actually not satisfied. So what non-interactive would mean is it would mean that messages go exclusively from prover to verifier. And in the protocol I described, I have to start off by sending them a message, right? So I cheated, and this is an interactive protocol. We could make it non-interactive. It's just, it really breaks up the flow of the story. And so, we could talk about it later if you care. But you can kind of, at least you get now what non-interactive means. You have a non-example of it. And then argument of knowledge, that's kind of clear. It's an argument that they know how to solve the cube. So this, obviously a made-up example. Why don't I talk about how we would actually use this on a blockchain? So on a blockchain, the prover is generally going to be a user of the service, of the network, and the verifier is usually going to be the chain itself. So what will happen is users will send proofs to the chain. They'll submit proofs to the chain, and the chain will act as verifier and check those proofs. So when the verifier is not a person but is a blockchain, then we have some constraints that we have to obey. We have to make our proofs succinct because the proof is going to go on-chain, and on-chain storage is expensive. The proof has to be quickly verified because on-chain computation is expensive, right? The proof is going to go on-chain, and that's a public ledger, and so the zero-knowledge property is essential because if your proof contains some secrets that you wish to hide, then it's obviously not appropriate to put that on-chain where the whole world can see it. And the non-interactivity is, again, the blockchain, you don't want to have to ask for messages from a chain. You want to post messages to a chain, right? So you, the prover, you ought to send messages to the chain. So you would like non-interactive protocols. That right there, that's why those letters pop up all the time in blockchain privacy, right? ZK SNARK, it's just this acronym that defines a bunch of properties, and now I hope you kind of understand why we need those properties for a blockchain application. I'll wrap up by just maybe discussing what more realistic statements we might use on chain. Not filtering for Rubik's Cube tutors, but doing important things. So one kind of statement that comes up all the time is, I possess the keys to a wallet that contains one dot. That contains one dot. Right, that is a thing that you may wish to prove on chain. Maybe you're not actually spending that. Maybe you just need to demonstrate to someone that you have it, right? Well, you obviously can't post the secret key on chain to prove it to them. But if you can come up with a ZK snark for that statement, then you can convince them that it's true without revealing your secrets. Or if we replace 1 ETH with like an NFT, then you can prove that you're a member of a given community, right? I prove the statement, I have the keys to a wallet that contains an NFT from this collection. Now I've proven to you that I'm a member of some online community. If roll-ups are your thing, then you might want to prove the statement, I have verified a batch of 10,000 transactions. And instead of actually verifying those on chain, maybe you can just submit a proof that you did it on chain, and the chain can verify that proof, right? And we start getting ZK rollups. I think that I've used up my time, so I'm not going to go through Manta's private payment protocol, but it is a really cool example of how these get used, and I'm here today and this weekend, so if you want to talk about it, I'm happy to explain it. But yeah, I hope that you got something out of that, and thanks for your attention.
Thank you, Todd. That was great. So, does anyone have some? Okay, we have one question.
Hey, Todd. Thanks a lot for the presentation. It was really amazing, very intuitive, and very entertaining. Thanks. And also thanks a lot what Manta Network is giving to the whole Polkadot ecosystem with your privacy technology. I think it's really great what you're doing. Also very much believe in privacy. I think it's a basic right for the people, but I think also for the adoption of blockchain technology for businesses, for example, privacy is really important. They don't want to expose what kind of transactions they do. Competition should not know all those secrets. But I think there's an elephant in the room, namely what happens to Tornado Cash this summer. This is really a shame because now there are a lot of naysayers that say that this kind of technology at the end is only used for money laundering. It's a real shame. I'm frustrated by this. Also, a developer had to go to jail for whatever reason. Maybe there was really some shady thing going on. But what do you think about that? And what do you think how the blockchain world can solve this kind of misunderstanding about privacy technology?
Well, thanks for those kind words, and yeah, it's a great question. I think one thing that has to be said is code is speech, right? Code is speech, and that doesn't escape the fact that, you know, there is a great deal of power that does not want people to transact privately, and part of that is because there are actual bad guys who want to transact privately. But there's also, like you said, privacy is a human right, and there's a whole host of good guys who want to transact privately. And like neutral guys, you know, neither good nor bad, who want to do it. I think that one thing that, and this is in the MantaPay protocol and not a part of the Tornado Cash protocol, is that you can actually incorporate optional compliance into such a protocol. So we have a system, and it's not unique to us, but we have a system of viewing keys. So there's sort of a hierarchy of the spending key that I must keep secret, and the public key that I can publish to anyone who wants to send me money. In between these is a verifying key that would allow somebody to decrypt my on-chain transactions, but not to spend the money that's in my wallet. And so if you need to comply as a business, for example, right? Businesses are a great example of this. They need to comply to certain entities. Well, they can share a verifying, they can share a viewing key with those entities, and that would unshield the transactions that they've made on chain, right? Without giving that entity the ability to spend their assets, right? So this is, I mean, one approach to that question is to try to find a middle ground, right? Where privacy is default and you have the option to sacrifice some privacy for compliance purposes. Yeah, I hope that answers your question.
Okay, anyone else? Okay, Todd, thank you for your great talk, but honestly, I missed one thing. Do you know what I missed? there was one thing missing,
What was that?
and it's real Rubik cubes. So we could actually try if we can solve that, right? How we can answer if we can try.
Okay, I'm gonna talk to Manta about getting some Manta branded cubes that I can pass out at this talk.
I think you need that.
Yeah. Hey, thanks for the invitation.
Applause for Todd. Thank you, Todd.